to once again congratulate and thank those that continue to follow up our work on YouTube and to attend these lessons on BBC, BBS TV. I want to encourage you to continue watching BBS TV and continue reading, continue following each and every piece of work that you have. Back to the number I left. We had managed to derive an expression which I want to start with. We had derived that expression from the original equation, so I will start from here. And we are given that the first initial approximation was supposed to be taken as pi out of 4, and we were supposed to show that the better approximation to this x naught is supposed to be pi out of 8. We will be substituting. So the better approximation which we want is actually x1. And our x1 is going to be equal to 2 times pi out of 4 times the sine of 2 times pi out of 4 plus the cos of 2 times pi out of 4 over 2 plus 2 the sine of 2 times pi out of 4. Candidates are expected, like I told you, my last statement was that you either use radians or you put in pi as 180 degrees. I will say that it is important for you to note that pi is 180 degrees, which further implies that pi out of 4 is 45 degrees. But if I simplify this, my x1 will become pi out of 2. 2 times pi out of 4 will give us a half. The sine of pi out of 2 again, plus the cos of pi out of 2 all over 2 plus 2, the sine of pi out of 2. At this stage, if you are using a calculator and you feed in pi as 180, that means that the sine of pi out of 2 is actually the same as the sine of 90 degrees. If you convert it to degrees, these are in radians, and this is equal to 1. But at the same time, the cos of pi out of 2 is the same as the cos of 90 degrees, and this is equal to 0. From your trigonometry, you should be aware of this. And therefore, if I substitute finally with that knowledge, my x1 will be pi out of 2 times 1 plus 0 over 2 plus 2 times 1. If I complete this, I will say that my x1 will actually become pi out of 2 divided by 4, which is rearranged to give us pi out of 2 times 1 out of 4, which eventually gives us the pi out of 8. So those that tried should have got that better approximation as pi out of 8 as was expected to be shown. As was expected to be shown. We shall be going straight to the next number. The next number is right over there. I am sure, my dear students, right in your living rooms at home, are able to see our next number. That is the next example. I want to mention that all these examples are unique in their own way, and they are telling us to show that the root to the equation, I will write the equation over here. The equation is sine of x is equal to the ln of x. Show that the root to the equation lies between x is equal to 2 and x is equal to 3. In other words, they want us to show that there is a root between 2 and 3. That root must be greater than 2 but less than 3. And later, they want us to derive a Newton Raphson formula for approximating this root. We shall let the function that we generate from here by taking this on the left-hand side be equal to the sine of x minus the ln of x. That will be our function, sine of x minus the ln of x. And since the root lies between 2 and 3, remember the condition is we are supposed to feed in 2 in our function and feed in 3 in our function. In other words, if my x is here and my f of x is here, then we are expected to find the values of f at x is equal to 2 and f at x is equal to 3. And if indeed there is a root, as they say, there will be a change in sign between these two, or their product will be less than 0. So if we consider x as 2, we shall find our f of 2 as the sine of 2, minus the ln of 2. You will be expected to use your calculators. And this implies that your calculators, since 2 is very small, an angle should be in radians. We are going to get this value and repeat this for the f of 3, which will be the sine of 3 minus the ln of 3. When you compute this, you should be able to get 0.2162, 0.2162, and negative 0.9575, 0.9575. And we say this is 0.2162, and this is negative 0.9575. So we conclude and say that since f of 2 times f of 3 is less than 0, then there exists a root between x is equal to 2 and x is equal to 3. Since there is a change in sign of our function, we confirm the existence of a root right over there. We confirm the existence of the root right over there. We confirm the existence of the root right over there. This should be your conclusion. As we said, you can alternatively say that 2 is less than the root, and the root is less than 3 after obtaining those values. I have emphasized that in order for you to find this value, your calculator should be tuned to be in radians for you to get the sine of 2 and the sine of 3. We shall proceed to part B of that number. Part B of that number. One thing that this concept requires is that students should have the knowledge of differentiation. Part B, they want us to derive a formula. And we already have a function, f of x, which is the sine of x minus the natural log of x. We are expected to differentiate, but I will illustrate And I will use a recall. I said that for these lessons, even the lessons in the normal school when I'm teaching, the word recall means I am going to use a fact that was shared much earlier or in our previous lessons. We already know that d by dx of the sine of x is cos of x. I expect all students that have been consistently attending these lessons to know how we get that. And for this one, I will show how it is got because we have not differentiated this, but I will say that d by dx of ln of x is actually equal to 1 over x, and I want to show how. I want to show the working quickly because it is important that I use what you know where it is coming from. I will let y to be equal to ln of x. But ln of x is the same as natural log. It's the same as the log to the e of x. And therefore it implies that I am saying that my y is equal to the log to the e of x. We want to show how we get 1 out of x. This is further written as e to the y using the rules or the laws of logarithms is equal to x. If we differentiate with respect to x, we shall get e to the y dy. I'm differentiating at a go, will be equal to dx. Why? If you differentiate e to the y, it stays the same. But if you differentiate x, it becomes 1. And 1 times dx, for those who may be saying, where has it come from? Our interest is to get dy by dx. So I will divide by e to the y dx throughout. E to the y dx throughout. E to the y dx. The e to the y here will cancel, and I'll get dy by dx. Now, the y by dx will be 1 over e to the y, 1 over e to the y, because the dx will also cancel. But e to the y is x. E to the y is x, implying, therefore, that my dy by dx is actually 1 out of x. Now, if I proceed to use this concept, I'll use it when the learners following know where it is coming from. We don't want any gambling here. Mathematics is a factual subject. You must be able to justify the source of whatever we are using. Now I can proceed and differentiate. I can now confidently say, hence, my f of x is when I differentiate sine, we said we get cos. So I will get cos of x and minus 1 over x. Therefore, my f of xn will be written as the sine of xn minus the ln of xn, and my f inverse of xn will be equal to the cos of xn minus 1 over xn. The derivative function, this one, must be seen by the examiner if you are to score. So using the general expression, xn plus 1 is equal to xn minus f of xn over the derivative of f of xn, we are going to substitute. So my xn plus 1 will be our xn minus. My f of xn is right over here. So it will be sine of xn minus 1, my f of minus ln of xn, minus ln of xn. That is this one, over the cos of xn minus 1 out of xn. There must be brackets here. I should be able to emphasize that. We take the LCM. Xn plus 1 will therefore be equal to, our LCM is cos xn minus 1 over xn. If we divide it here, we shall have our xn into the cos of xn minus 1 over xn minus times sine will become minus the sine of xn and plus ln of xn. Caution that we must be extremely careful right here to ensure that we get the right expression without making any mistake. So I will open up finally, and I will stay with our xn, the cos of xn minus 1. These times this will give us 1 minus the sine of xn plus the ln of x to the n, everything over the cos of xn minus 1 over xn. We shall leave our expression here. This is the expression we shall consider to be the formula that we are going to use. And it is important to note that n is an integer that starts from 0, 1, 2 onwards as we take up the approximations. Derive the Newton Raphson formula for approximating the root to the equation, and that was what they wanted us to derive. We have been able to derive the expression. Can I request the producer to take us to the next page? That question was telling us to derive. I'm requesting the producer to take us to the next page. I expect that there is a question there. Okay. Before we go to number 4, there is a question that was not captured. Let us focus on that question. They are telling us to find the root of this equation. We are still on this number. There is a part where they are saying, find the root. It is important that we go through it. Find the root of this equation. Find the root of this equation. That part is missing. As you notice, there is a missing part for number 3. Meanwhile, number 4 will be our next number, but we are still on number 3. We want to find the root. Now, to find the root, it is important to note, and I want the students following this lesson to note, that they can ask you a question and tell you to find the root when they have not given you the first approximation. So it is important that you revisit our expressions. F of 2 gave us 0.2162, and f of 3 gave us negative 0.9575. By looking at these values, given that we consider convergence towards the correct root, This, when x is 3, we get a negative. It means that this value is far from the correct root. The 3 is far from the correct root compared to the 2. So, since this is nearer, we shall let our first approximation be 2.0. 2.0. We are going to look for the root to the equation to 3 significant figures. When they tell you 3 significant figures, it means it is going to help you to get the tolerance. Our tolerance will therefore be 0.005. 0.005. This is our error range. So we shall start with this one and look for our x1. We shall start with that one and look for our x1. I hope you've captured this so we can start right away. So if I put in my value of 2 in this expression, it is very big or very long. We can say it is 2 times the cos of 2 minus 1 minus the sine of 2 plus the ln of 2, everything over the cos of 2 minus 1 over 2. As I told you, it is important that you use your calculators there, and your calculators must be in a radian mode since 2 is small and angle to consider. If you use your calculators there, our value of x or x1 should be 2.236. 2.236. I can now rub off here. I can rub off here. Can rub off here so that we can proceed. Now, you are aware that we are supposed to check for the convergence. Therefore, we get our x. Even if we get x naught minus x1, we take the modulus and we see what we get. Our 2 minus 2.236 will give us a value, of course, of 0.236, and this value is greater than our tolerance of that. It is not until when we get a value that is less that we consider the root we shall have got to be the approximate root. So, we proceed and look for x2. With x1 as 2.236, we want to get x2. We repeat the same expression. Our x2 will become, substitute here again, 2.236 times the cos of 2.236 minus 1 minus the sine of 2.236 plus the ln of 2.236 all over the cos of 2.236 minus 1 over 2.236. Again, using our calculators, we try to find the value of these answers. So our x2, if we compute using your calculator, and again I warn you that we are expected to have got a value. We are expected to have got a value that is equivalent there is something I'm noticing here in our multiplication here. There is something I'm noticing that should have been corrected. In our final expression, this should have been squared, since this was taken as 1. if we took an LCM in here, this should have been squared, and there should have been an xn here. I'm noticing that, which is very, very important. Which is very, very important. So this should have been squared. So if that is squared, it comes in here, which I think people have noted. If that is squared, upon computation, students are expected to get a value of our x2 as 2.219. 2.219. 2.219. And when we get this value, we again check for convergence. x2 minus x1 modulus will give us 2.219 minus our previous value is 2.236. When we get this value, it gives us a value of 0.017. 0.017. 0.017 is still greater than that. 0.017 is still greater than our tolerance value. So we try to look for the third value, given that our x2 is now 2.219. Our x3, we substitute again here, will be 2.219. This is squared times the cos of 2.219 minus 1 minus the sine of 2.219 plus the ln of 2.219 all divided by 2.219 times the cos of 2.219 minus 1 over 2.219. This is in a bracket. If you compute this, you will get a value of x3. If you compute that, you will get a value of x3 the value of x3 that you get will actually still be 2.219. 2.219. Now we can confirm that x3 minus x2 will give us a value that is 0. 2.219 minus 2.219 will give us 0, and 0 is now less than that. And hence, we conclude that the root to the approximation of the function is 0.21 is 2.219. They say to 3 significant figures, which will be 2.22 to 3 significant figures. That will be the root for the expression that we have been working through. That will be the root. That will be the root. I want us to now take a moment and look at number 4. But it is important that students note that if you have a trig function, you must actually use your calculator in radians if you are going to get correct computational values, as we have seen. Number 4 is right over there for you to see. I will request that you can now, I will request the producer to make sure that you are now able to see number 4 and 5. Number 3 is fully done. So that we work through number 4 and you can be able to try out number 5 in case we are not able to go through it. Number 4, like I said, all these numbers are unique, and that's why formally I have not come out to give you an exercise, because I'm still looking at the different technical numbers. Example number 4. However, you are now expected to be able to actually try out these numbers and get them right. They are saying we derive a Newton Raphson formula for finding the square root of a number n. To find the square root of a number, we shall let x, which is our variable, to be equal to the square root of n, as stated. If we let x be equal to the square root of n, we need to find the function. If we square both sides, we shall have x squared actually being equal to n. And this will imply that the function, it implies that the function f of x, which we are looking for, can be written as x squared minus n. The function can be written as x squared minus n. The function can be written as x squared minus n. And we need to get the first derivative. This is simpler. We are differentiating with respect to x, so we shall get 2x. Since n is a constant, it will disappear. Also, if we consider xn, the first approximation, our function can now be written as xn squared minus n, and our derivative to the first level or degree can be written as 2xn. So using our Newton Raphson formula, standard formula, xn plus 1 should be equal to xn minus f of xn over the first derivative of xn. If we substitute in these two values, this one and this one, our xn plus 1 will be equal to xn minus our xn squared minus n. Don't forget these brackets, over 2xn. We do the mathematics by taking the LCM. The LCM is going to be 2xn. We divide it here. It gives us 2xn times xn, which is 2xn squared, minus xn squared plus n when we open brackets. This is our xn plus 1. But 2xn squared minus 2xn squared is like 2 oranges minus 1. You have 2 oranges, you take away 1 orange. If I let xn squared be an orange, 2 oranges take away 1, you will definitely stay with 1. And our formula, which they want us to find, our formula therefore, xn plus 1 will become xn squared plus n over 2xn. This is the Newton Raphson formula that is expected to be obtained by the candidate. And remember to write that your n can take on n of these values when we begin looking at the approximations. They go ahead to tell us to find the square root of 7. Find the square root of 7 given that x naught is 2.1, and they want us to write our answer to 2 dp's. When they talk about 2 dp's, it implies that our error is going to be 0.005. We have not discussed errors, but there is a technique of picking an error in a number. If a number is to 1 decimal place, this is made a 0, and that is 5. So the error in this number is 0.05. If it is to 2 decimal places, if I added 1, it is 0.00, then you put a 5. So if they tell us that we want the answer to 3 decimal places, then it is important to note. From here, the students should note that since we started with x as the root, therefore our n is going to be 7, and our x naught has been given as 2.1. So our first approximation, x1, will be obtained by feeding in here our n as 0. When we feed in our n as 0, it means we are feeding in this value. So our x1 will be equal to 2.1 squared plus n, which is 7, over 2 times 2.1. I will expect you to use your calculators and compute. And the pause that I normally put is to allow you to get the value before I put it there. I'm buying time for you to compute using your calculators and get our value for x1. Because they want the answer to 2 decimal places, we write our expressions to 3 decimal places, and we shall eventually round off. The first approximation gives us this. We check for our error. 2.717 minus 2.1 modulus will give us 0 point. If we subtract here, we have 0.617, which is definitely greater than this. That means we take on the next iteration to look for x2. Our x2 is what we want. Our x1 is now 2.717. We repeat. Our x2 becomes 2.717. It's a pattern. Once you've mastered it, it is an easy-to-do number. Again, I wait for you to compute and tell me what you get there. When you feed in 2.717 squared plus 7 divided by that, what do you get? You'll get 2.647. We again check for the error margin. Is it yet less than 0.05? If it's not, we have not reached the answer. If we subtract this 2.647, we take away 2.717. We use the modulus so that even if the answer is negative, the modulus automatically makes you write the positive equivalent. If we subtract from here, you notice you'll have a 0, you'll have 11 minus 4, which will be 7. You have a 6 here, which is a 0. So you have 0.07 0, and that figure is still less. 0.070 is still greater than our error. So we take on the next iteration, and once the value becomes constant, we are looking for x3. Our x3 will be 2.647. This is squared plus 7 over 2 times 2.647. When we compute this, it will give us a value that I will again give you an opportunity to test and check. It gives us ideally the same value, 2.647. And we can say that 2.647 minus 2.647 modulus should now give us a value that is less than 0.005. And hence, we conclude once the value is less than 0.05, we conclude that we have got the answer. We conclude that the square root of 7 indeed is 2.647, but they told us to how many decimal places? To 2 decimal places, which we shall say is approximately 2.65 to 2 dps. The square root of 7 becomes exactly 2.65. The other concept that requires you to do this is in paper 1, where you are supposed to use some differentiation method to find square roots of a number. Newton Raphson also helps us to find the square root of a number without directly using the calculator to get. If you use the calculator directly here, it should be able to give you approximately this value. And this is expected to be more accurate an answer than when you are using the differentiation from first principles. There are small changes. We have number 5. We have number 5. And I think we can utilize the time available at least to derive the Newton Raphson formula, to show that the Newton Raphson formula is given by that expression. Number 5, part A. Number 5, part A is what we are going to do, and once I derive that expression, I will expect my learners out there to actually complete the number. I will expect my learners out there to complete the number. If you can squeeze that number so that even part C is visible to the candidates out there, that would be great. You squeeze it a bit, part C, so that it is also visible. Right over there. Thank you. My dear learners, let us take on number 5. Let us take on number 5. But just in case you've not finished capturing this solution, for number 4, the whole solution is still on the blackboard. And you can have an opportunity to take a picture. But I expect that you actually have got the working. The approach is not different. It is the expressions that are differing. The formula is the same. So we are taking the same route to a known destination, which must be the answer. Number 5A, which I am very sure we are going to finish. Part A we are going to finish. They are saying show that the Newton Raphson formula for finding the kth root of a number is given by that expression, where the number is A. Now, I will let us know that if we talk about square root, let me start with this. If we talk about square root of a number A, it can also be written as A to the power a half. If we talk about the kth root, this is a square root. If we talk about the cube root, we write it as this, if it is a, and we write it as a to the power a third. So if we talk about the kth root, it is a to the power k, which we write as a to the power 1 out of 1 over k. That will be the interpretation. So with this, I will let x be equal to a to the power 1 out of k. And we already know that, of course, 1 out of k can be, from our previous example, we can square this, both sides. We can multiply by the power of k, by the power of k. So we shall have x to the k is equal to a 1 out of k to the power k. This will mean that x to the k is actually equal to a, implying that x to the k minus a is going to be our function. X to the k minus a is our function. If we differentiate, our f of x is x to the power k minus a, and our first derivative is going to be k multiply the power, reduce the power by 1, and of course this one will disappear. Our f of x to the n will be xn to the k minus a, and our f prime of xn will be k xn k minus 1. What follows next is a substitution in the general formula, and like I told you, in a minute or two we shall be done, because it has just one step. Using xn plus 1 being equal to xn minus f of xn over the derivative of f of xn, we shall have our xn plus 1 being equal to our xn minus our f of xn is xn to the k minus a over our derivative is k x n k minus 1. If we take the LCM, we are using indices. Our xn plus 1 will actually be this xn into kxn k minus 1 minus xnk plus a all over k xn k minus 1. Finally, our expression will be xn has a power of 1 times this. This power will cancel with that. So we shall have xn to the k only times k. We shall have k times x to the power k minus x to the power k plus a over k x n to the power k minus 1. This is factorized to get the final expression as xn to the k is common. So we shall have k minus 1 plus a all over k xn to the k minus 1. This gives us the expected expression. they go ahead to tell you to find the fifth root of 64. That means 64 will be the number they want you to find. I will just give you a few numbers to try out in addition to this number. Feel free to try out some more numbers that are available in the question bank book. 19, I will just give you two. 1998, number 10. This is March. And then 1996, number 13. And 1998 again, number 9, and this is November. When we meet next, I must assure you we will be able to wind up this topic. I want to wish you the best. I want to thank those that are following my YouTube channel and to continue to thank the people that make things happen here on BBS TV. I wish you a good week. God bless you. Gachari Mabaga.
Somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi lusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory, ssaako ne computer lab wamu ne bw'osomeseza omwana wo mu masomero ga Giant Schools omuli kampasi y'e Bombo Kalule n'ey'Ekabalagala tobona bweraliikirivu bwonna olw'omusingi okutambuzibwa ebyenjigiriza n'ensoma y'abayizi ey'omulembe. Mu masomero gaffe gano gonna tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuuka ku siniya ey'omukaaga nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. Ebibiina abaana mwe basomera eby'omulembe omuli buli kimu ekikwata ku ebyo bye basoma. Ebisuula ebyazimbibwa obulungi, ebigazi ate nga biyonjo. Okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga. Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory, ssaako ne computer lab. Abasomesa baffe abatendeke mu kusomesa n'okubangula abayizi kuno nga twongerako n'okukulembeza ebitone. Kati nno ggwe omuzadde omwana wo mulete mu kifo kimu kyokka ekigenda okumuyamba okwongera okunnyikiza ebyo by'asoma era ng'essomero liri limu lyokka ye Maryland High School erisangibwa Entebbe. N'okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga.
Baby Junior Jelly owulira omukwano gwa maama n'okufaayo kwa maama. Baby Junior Jelly owulira engalo za maama ansingira bulijjo anyiriza buli kadde. Baby Junior Jelly abatogo beetaaga.
Nze nga jjajja bazzukulu bange okusanyuka n'okufuna emirembe. Ekyama kyange mbasiiga ebizigo bya Baby Junior Jelly biwummuza bigonza olususu lw'aba baby birimu akawowo akalungi bigoba okubutuka okuleetebwa diapers birungi ne ku nsusu ez'entondo.
Baby nduya.
This year, the Rolex Festival is coming to your home. Okutandika ng'ennaku z'omwezi 8 August. Tugenda kubeera ne Rolex Festival Home Edition with lots of your celebrities. Nga bakulaga how they make their Rolex. The Rolex Festival Home Edition egenda kubeera buli Lwamukaaga ne ku Sunday from 5 p.m. ku Rolex Festival Facebook page powered by Coca-Cola, Uganda Tourism Board, Total Gas, Microfinance Support Center, Rolex Yo, and
AfriCell, connecting communities. AfriCell is regulated by Uganda Communications Commission
and organized by the Rolex Initiative.
omuzadde ng'oteekateeka okunoonyeza omwana w'essomero ery'okumubangula mu bintu eby'enjawulo omuli ebyenjigiriza eby'omulembe n'okufuna amagezi ku bintu eby'emikono, essomero liri limu lyokka, Janan Nursery and Primary School erisangibwa ebbombo Kalule. Ffe tulina omusingi gw'ebyenjigiriza ebisookerwako nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. Ebibiina abaana mwe basomera eby'omulembe omuli buli kimu ekikwata ku ebyo bye basoma, ebisuula ebyazimbibwa obulungi, ebigazi ate nga biyonjo, kompawundi yaffe nga zi bulungi, nga n'endabika yayo eyamba omwana okulowooza ku ebyo by'asoma. Abayizi baffe bafuna akadde ak'okusinza mu madiini gaabwe ag'enjawulo. Wano ku Janan ebyokwerinda tubitwala nga kikulu, anti tulina security camera ezisangibwa mu buli kasonda k'essomero. Abayizi baffe baweebwa omukisa okwetaba mu by'emizannyo eby'enjawulo omuli okuwuga, okusamba omupiira, basketball n'okuzannya netball. Tufaayo ku by'obulamu nga tulina eddwaliro erikola okumala essaawa 24. Endiisa y'abaana ezimba emibiri gyabwe n'okubakuma nga balamu. Kati nno gwe omuzadde ekirabo ky'oyinza okwasa omwana wo mu lusoma lw'omwaka 2020 muleete ku Janan Nursery and Primary erisangibwa ebbombo Kalule, nga n'okwewandisa kugenda maaso kati eri abaana ab'ekibiina ekisooka. Okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga.
Okwewala oba okwekuuma akawuka ka COVID-19 akalumya ensi yonna, bino wammanga by'olina okukola okuziyiza okusaasaana kw'akawuka kano aka COVID-19. Naaba engalo ng'okozesa amazzi ne sabbuuni buli kadde. Weewala okubeera mu bantu abangi buli w'obeera. Weewala okukwata mu maaso, ku nnyindo, ku mumwa n'engalo nga si nnyonjo. Kolola oba nyiza mu nsonda y'akakokolako oba okozesa akatambaala bw'omaliriza okasuule mu dustibini yo. Bw'ofuna obubonero obulaga COVID-19 sigala ewaka okubire aba Ministry of Health ku 0800-100-000-666 oba ku 0800-20-30-33 okufuna obuyambi. Wabula bw'oba oyagala kuzza bujja intaneti yo eya Rock Telecom, kozesa emikutu gyaffe egya digito nga Mastercard, Visa ne ba agent. Osobola okunyiga *252#. Sigala ewaka, sigala nga weekuumye, sigala ku Rock Internet.
Rock Telecom.
Tosubwa ku BBS Telefina. Tosubwa.
BBS Terefayina yaffe.
Roundabout ewagidwa.
Kayibanda sente nga mwezi.
Sente zona bali zituta nene bandekera mukama nayamba.
Mukama nayamba drink alimu